Right then, let's talk about aeroplanes, specifically the bit that makes them go. You see, a plane sitting on the ground is just a very complicated and expensive glider. To get it moving, to get it up into the sky where it belongs, you need power. Lots of it. And that power comes from an engine. The engine's job is brilliantly simple, really. It has to turn fuel into forward motion or thrust, as the clever chaps in white coats call it. It does this by spinning a propeller, which is basically a set of wings that go round and round, pulling the airplane through the air. It's the heart of the machine, the noisy, beating heart that gives the whole thing life. Without it, you're just a passenger in a very fancy metal tube, waiting for gravity to win. The whole point of an aircraft engine is to create a force that pushes back against the air. Think of it like swimming. You push water backwards with your hands to move forwards. An airplane's propeller does exactly the same thing but with air, and it does it thousands of times a minute. The engine is the muscle that drives those hands. It needs to be reliable, powerful enough to lift thousands of pounds of metal off the ground, and efficient enough so you don't run out of fuel over the middle of nowhere. It's a massive job, and that's why there are different ways of doing it. The two big ones we're looking at today are the piston engine and the turboprop. Now, you might think an engine is just an engine, but oh no, that's where you'd be wrong. The way these things make power is completely different. It's like comparing a classic V8 muscle car to a high-tech electric supercar. They both get you down the road, but the experience and the engineering behind them are worlds apart. One relies on controlled explosions, a very mechanical and familiar process, while the other uses a continuous blast of hot gas, which is a bit more, well, jet age. Understanding the difference is key to knowing why some planes buzz like a happy bumblebee, and others have that distinctive high-pitched whine. It all comes down to what's happening under the bonnet, or cowling in this case. So our mission, should we choose to accept it, is to dive into these two magnificent bits of engineering. We'll look at the piston engine, the granddad of aviation power that still has plenty of life in it. Then we'll explore the turboprop, its more modern and powerful cousin. We'll see how they work, what they're good at, and why a pilot or an airline might choose one over the other. It's not just about speed, it's about cost, reliability, the sort of jobs the plane needs to do, and how high it needs to fly. It's a fascinating world of mechanics, fire, and raw power. Let's get started. First up, the piston engine. If you've ever looked under the bonnet of a car, this will feel very familiar. It's basically the same idea. You have cylinders, and inside each cylinder, you have a piston that moves up and down. It works on a simple four-step dance. Suck, squeeze, bang, blow. First, it sucks in a mixture of air and fuel. Then the piston moves up and squeezes that mixture into a tiny space. At just the right moment, a spark plug ignites it, causing a small, powerful explosion. Bang! This explosion shoves the piston back down with great force, and that's what creates the power. Finally, the piston moves up again to blow the leftover exhaust gases out. This up and down motion of the pistons is then turned into spinning motion by a crankshaft. It's a brilliant piece of mechanical engineering, really. All those little bangs happening in perfect sequence across multiple cylinders create a smooth, continuous rotation. This rotation is then sent directly to the propeller at the front of the aeroplane. So every time you hear that classic deep rumble of a small plane like a Cessna or a Piper, you're hearing a series of very carefully controlled explosions. It's a technology that's been around for over a century, and while it's been refined, the basic, brilliant principle remains exactly the same. It's reliable, relatively simple to work on, and gets the job done. The beauty of the piston engine is its simplicity. Because it's so similar to a car engine, many mechanics understand how it works. Parts are generally cheaper and more widely available, especially for the more common models. This makes owning and operating a piston engine aircraft a lot more affordable. They are perfect for smaller planes, the kind you might learn to fly in or use for a weekend trip. They don't produce enormous amounts of power compared to their bigger brothers, but they produce more than enough to get a 2- or 4-seater plane airborne and cruising along at a respectable pace. They are the workhorses of general aviation. However, there is a catch. Piston engines have a lot of moving parts rubbing against each other. All those pistons, connecting rods and valves create a lot of vibration and require a lot of maintenance to keep them running smoothly. They also lose their puff as you fly higher. The air gets thinner the higher you go, which means the engine can't suck in as much air for its air-fuel mixture. Less air means less bang, which means less power. So, while they are brilliant for flying low and slow, they aren't the best choice if you want to climb high above the weather in a hurry. Now for the turboprop. This is a different beast altogether. To understand a turboprop, you first have to think about a jet engine, the kind you see on a big airliner. A jet engine sucks in air at the front, squeezes it with a compressor, mixes it with fuel, and ignites it. This creates a continuous blast of hot gas that shoots out the back, pushing the plane forward. It's one big, long, continuous whoosh instead of a series of little bangs. It's incredibly powerful and efficient, especially at high altitudes and high speeds. It's a much smoother process with far fewer moving parts than a piston engine. So, what is a turboprop then? Well, imagine you take one of those jet engines, but instead of using all that hot gas to push the plane from the back, you use most of its power for something else. You put a turbine in the stream of hot exhaust gas. This turbine spins incredibly fast, like a windmill in a hurricane. This spinning turbine is then connected to a gearbox, which slows down the rotation to a suitable speed, and then it spins a propeller at the front. So, a turboprop is essentially a jet engine that drives a propeller. It's a hybrid, taking the best bits of a jet engine and combining them with the efficiency of a propeller at lower speeds. This setup gives you some serious advantages. Because the core of it is a gas turbine, a turboprop produces a phenomenal amount of power for its size and weight. It's much more powerful than a piston engine of the same size. This means planes with turboprop engines can be bigger, carry more people or cargo, and climb much faster. They also perform brilliantly at higher altitudes where piston engines struggle. The turbine's compressor crams air into the engine so it doesn't care as much if the outside air is thin. You can fly up high above the bumpy weather in smooth, clean air. The experience of flying in a turboprop-powered plane is also different. They don't have that low-frequency rumble of a piston engine. Instead, they have a distinctive high-pitched whine from the turbine spinning at tens of thousands of RPM, combined with the hum of the propeller. Because the power delivery is from a continuous combustion process, they are also incredibly smooth. There's far less vibration shaking through the airframe. This makes for a more comfortable ride for passengers and less stress on the aircraft's components. They are the perfect middle ground between piston power and pure jet power. So, when it comes down to it, which engine do you choose? Well, it all depends on the mission. Let's start with the most important factor for many people: cost. Piston engines are the clear winners here. The engines themselves are much cheaper to buy, and the maintenance costs are significantly lower. A complete overhaul of a piston engine, while not cheap, is a fraction of the cost of overhauling a complex turboprop. This is why you see them on almost all training aircraft and smaller private planes. For the private pilot or small flying club, the piston engine makes aviation accessible and affordable. It's the sensible, budget-friendly choice. But what if you need more grunt? This is where the turboprop shines. In terms of power-to-weight ratio, it's no contest. A turboprop engine is lighter and produces vastly more power than a piston engine of a similar physical size. This is why you see them on larger aircraft, like regional airliners that carry 50 to 70 people, or on utility planes that need to lift heavy loads out of short, rough airstrips. Think of a plane designed for skydiving or for dropping supplies in remote areas. You need to climb fast and have power to spare. The piston engine simply can't compete in that arena. The type of flying you do also dictates your choice. If you're happy just pottering around on a sunny afternoon, flying a few thousand feet above the ground, a piston engine is perfect. It's most efficient at these lower altitudes and slower speeds. However, if you need to fly long distances or get above bad weather, the turboprop is your friend. They are designed to operate efficiently up high between 15,000 and 25,000 feet, where they can cruise at much higher speeds than a piston-powered plane. This makes them ideal for business travel or for short-haul airlines that need to stick to a tight schedule, rain or shine. In the end, it's a classic case of horses for courses. The piston engine is the reliable, affordable heart of general aviation. It's like a trusty family car. It's not the fastest or the most glamorous, but it's dependable and does its job beautifully. The turboprop, on the other hand, is the high-performance utility vehicle. It's more expensive to buy and run, but it offers a massive leap in power, speed, and altitude performance. It bridges the gap perfectly between the world of small planes and the world of big jets. So one isn't better than the other. They are just brilliant at different things.